biggest thing that determines if a transformer is step up or step down is the coiling ratio between primary and secondary coils. And that's where our equation comes in. So this is, the switches and the magnetic fields are important, but this is the most important piece. So here's the deal. So here's the iron core, here's the primary coil, here's the secondary coil. If you have, on the secondary coil, if there's a greater concentration of wires, then you'll increase voltage, because what this does is increase current. There's more pathways for a flow of electricity. So if there's a higher ratio of secondary coils to primary coils, that will be a step-up transformer. And the voltage leaving the transformer will be greater than the incoming voltage. Okay, so if power is leaving a power plant to go to the grid, this would be, you'd have a really large step-up transformer to do that. Okay, this is a step-down transformer, and this is a kind of step transformer that we would have, on our power lines outside of our communities, in order to make sure that we have a good amount of electricity that's controlled. So this would be energy coming in off the grid into your home. So you'll have a large amount of coils on the primary coil, and then a smaller amount of coils on the secondary coil leaving the iron core. So this decreases the voltage. So this decreases the amount of electricity entering your home. So that's called a step-down transformer. That's a good thing, or else we would blow our grids. Okay, so with coiling, so you can see this again. Step up, higher concentration of coils on the secondary coil from the core. Step-down transformers have a lower amount of coils. All right, so if we increase the amount of coils on the secondary coil, it creates a step-up transformer. This increases the voltage of the output current. And if we decrease the amount of coils on the secondary coil, that creates a step-down transformer. And this decreases the voltage of the output current. So you can see where this is useful as well. So make sure you read this over on my notes. Okay, this would be not complete without a picture of Optimus Prime. But so transformers, right? So power in equals power out. So energy can't be created or destroyed. There has to be a balance between current and voltage as the number of coils change in transformers. Right? So in a step-up transformers, voltage increases in the secondary coil in comparison to the primary coil. Current will decrease, however. In step-down transformers, voltage declines, but current increases. So you have an equal distribution of electrons in both cases as a result. Okay, so here's our transformer equation, and it's right here in your, again, that's on page 3 of your data booklet. So N stands for the number of, so NP is the number of primary coils, and S is the number of secondary coils. This is primary voltage, VP. This is secondary voltage. This is current, so secondary current, IS, and primary current. So you have these ratios. Okay, and that's what this looks at. So we can use these equations interchangeably in order to solve for voltages and numbers of coils and primary and secondary currents. Okay, that's what this shows here, right? So transformer equation, right? V equals voltage, N equals number of coils, I equals current. The underscore P is primary, and the underscore S is secondary. Okay, this is the last slide for this section of the unit. I'm going to show you a question. So you have practice problems on page, you have a practice example on page 401 with transformer questions. Page 402, this is what I'm going to look at. Okay, so page 402. This is number 50. Okay, so it looks at this. electrical grid with transformers and houses. Okay, so question 50 says the transformer on a power pole takes an input voltage of 4.0 kilovolts and delivers 240 volts to a home. So I'm going to write this down right now. So 50, so my voltage primary, I'm going to convert that to volts right away. So kilovolts is 1,000. So I've got 4,000 volts as a primary voltage. And then 240 volts, so secondary voltage to a home. So the first question is this a step up or step down transformer? So the answer would be obviously step down, so because the voltage decreases. Okay, so that's A. B asks if there are 180 turns of wire on the secondary coil. Determine the number of turns of wire on the primary coil. So this is, so NS equals 180 turns. Okay? And it wants to know how many turns are on the primary coil. So we're looking for NP. So I'm going to go to my equation. Okay. Where I have, this is on page 3 of my data booklet, NP over NS. Okay, NP over NS equals VP over VS. And we're going to do this ratio. So I have 180 over we're looking on the primary coil. So I have NP over 180. And on my primary coil I have 4,000, on my primary voltage I have 4,000 volts. Secondary voltage is 240 volts. Okay, so NP is going to equal 4,000 divided by 240 multiplied by 180. And that'll be the number of coils on the primary coil. So let's solve for that. 4,000 divided by 240 multiplied by 180. And there should be 3,000 coils on the primary coil. And that should make sense because the voltage is higher. So NP equals 3,000 coils. Okay, so again, this is page 402, number 50. Let's look at C. C looks at current. So this is saying if the maximum current supplied to the home is 100 amps, determine the current supplied to the transformer. So what's coming into the transformer is the primary current, and what's going into the home is coming from the transformer to the home. Okay, so my secondary current is what's going into the home because the transformer is before the home in the grid. So make sure that you understand that. So I could use I could use my coils or I could use my voltages in order to solve for the current that we're trying to figure out. So we're trying to figure out the primary current. So how much current of electricity is supplied to the transformer from this voltage. Okay, so let's use another part of the equation. So I have a VP over VS. Okay, and that's going to be IS over IP. Okay, so again, my primary voltage is 4,000 volts. My secondary voltage is 240 volts. I'm trying to find the current supplied to the transformer. So my secondary current is 100 amps because that's what's going into the home. And my primary current is what I'm trying to find. Okay, so let's do a little math here. Again, 4,000 divided by 240. That's 16.67. That equals 100 over my primary current. Okay, so let's do a little cross multiplication. All right, so I can cancel this. I'm going to end up with primary current times 16.67 equals 100. So this is going to be 100 divided by 16.67. And I'm going to get my primary current. And it should be less than 100 because there's a smaller current that's entering the home because there's less coils. So 100 divided by 16.67 is about 5.99 amps. That sounds about right. Okay. So those are all of your energy and power and transformer equations. There's more practice questions on page 403. Okay, specifically questions 3 through 8. Page 402, you have a few more. Page 51 is also a question that addresses transformer questions. Okay, I'm not going to do another one because that one's pretty straightforward. And then you've got page 405, chapter 1 review questions if you need more. Okay, so that's the end of the first section of electromagnetism. So you should be able to do now, well, actually you can do, and you can follow these, you can follow along with the lectures while you're doing these assignments. You can do the electromagnetism quiz number 1. You can do the magnetic field lab, and you can do the circuits lab. Okay, so I'm going to hold off on lectures for a little bit. The second part of this unit is slides 57 to slides 111, and we're going to talk about the electromagnetic spectrum, and we're going to be talking about space there. So this is the first part, which is the electricity part. The second part talks more about gravity. Okay, so that's it for this section of the unit. I might not post anything again until next week, so you have some time to work on this. Otherwise, if you have questions, please let me know. Bye now.